Hey guys, today's video is all about vector embeddings. We will see what are vector embeddings, their importance, and we will also see how to create vector embeddings using different platforms at the end of this video. Okay. So first things first, what are vector embeddings? So vector embeddings are a way to convert data into numbers that machines can easily understand and process. See, machines don't understand human language, right? So that is why we need vector embeddings that machines can easily understand and process. So as you can see in the image, the data from various sources, it can be structured, semi-structured, unstructured, it can be audio, video, image that gets converted into vector embeddings. So how does it happen? So we need an embedding model in between to convert that data into vector embeddings. And there are different platforms like OpenAI, Cohere, Hugging Face, and all these platforms provide us with different embedding models that we can use. So what happens basically? The data from various sources gets chunked. It's split and gets chunked, and each chunk is assigned with a numerical value using a embedding model. And that's how vector embeddings are created. And all these vector embeddings are stored efficiently in a vector database. And as you all know, there are numerous vector databases out there that you can use and store your vector embeddings. So this numerical representation, right? This numerical representation captures semantic meaning relationships, enabling machine learning models and large language models to perform different tasks like right sentiment analysis, recommendation systems, machine translation, and more. So so that's the importance of vector embeddings, and this is just an overview of how vector embeddings are created and stored. Thanks. Hey guys, so it's very important to understand how vector embeddings or vector data is represented or stored in a vector database. So as you can see, the similar type of words or objects are stored closer to each other in a vector database. For example, as you can see here, grandfather, man, adult, woman, boy, child, infant, girl, all these examples are stored are placed on x-axis and y-axis, x-axis being gender and y-axis being age. If you can see grandfather, man, so as a gender wise, it is they are placed together. And as you can see, infant, child, these two things are placed closer to each other because they have the similar meaning. So and how they are represented using word coordinates. As you can see, grandfather, it is 1 9, and man is 1 7. You basically need to see the x-axis and then the y-axis, and that's how just a simple representation of how vector embeddings are stored or represented in a vector database. Thanks. So you might ask, what are the types of objects that can be embedded and stored in a vector database? So, like I said, right, any unstructured data, even unstructured data, structured data anyhow, but even unstructured data like audio, video, image, anything can be embedded and can be converted into vector embeddings and can be stored in a vector database. Uh, as you can see here, right? Text, graphs, 3D models, molecules, anything. But what you need is an embedding model to do that. For example, as you can see, audio. If you have the audio input, audio data, that can be converted into audio vector embeddings using an audio embedding model. So there are examples like OpenL3 is one of the examples of the audio embedding model that you can use and convert your audio format data into audio vector embeddings. And similarly, we have GPT, we have OpenAI's embedding model for text, which can be easily converted into text vector embeddings. And for videos, we have YOLO, right, a video embedding model that can be converted into video vector embeddings. So basically, we need to understand that any unstructured data, structured anyhow, but any unstructured data can be converted into vector embeddings. But the only thing that we need is an embedding model. We need to find that embedding model that suits our data type. So that's the only thing we need to convert into vector embeddings. Yes. So we have different types of vector embedding, basically word embeddings, sentence and document embeddings, graph embeddings, and image embeddings. So like you might have heard about word2vec, glove, and fast text. All these are basically word embeddings. These are the most common ones, and that most of the AIML applications usually use. And sentence and document embeddings are these capture the semantic meaning of sentences and documents, basically. So BERT and doc2vec are some of the examples. And again, graph embeddings, these are used to represent nodes and edges of graphs in vector space, facilitating tasks like link prediction and node classification. I think now on the internet, many people are talking about, right, graph embeddings and graph vector databases. So these are becoming very important. And at the end, we have image embeddings. Like these represent images in a compact vector form and useful for tasks like image recognition and classification. So these are some of the examples of types of vector embeddings. So now that we have converted our data into vector embeddings and stored in a vector database, but how do you calculate the distance between the vectors, right? That's also very important, right? How machines calculate, or how when retrieving similar objects using semantic search or vector search, how this calculation is done. So for example, as you can see in the image data, that is unstructured data that we have, the cat and the dog, the images, which gets converted into vector embeddings using an embedding model, and that is stored in a vector database, as you can see here, right? So we have different methods to calculate the distance between the vectors, right? So we have Manhattan distance, we have cosine distance, we have dot product, and Euclidean distance. They all come under the semantic, or what we call vector search methodologies. Okay. So let's understand how these Manhattan distance, Euclidean distance, cosine distance, and dot product are basically calculated. Okay. So as you can see in the image, the Manhattan distance is calculated by using a step-by-step approach. As you can see, it's basically from point A to point B. It's just like stairs, like how we go on stairs from point A to point B. That's how it is calculated. And Euclidean distance is basically a straight line, like how a bird flies from A to B. It's just a straight line, right? That's how Euclidean distance is calculated. And cosine distance is basically the degree between two vectors, as we saw in our example, right? The cat, the dog, both are represented as vectors, and when you mark them and calculate the degree between these two, that is what cosine distance is all about. And in dot product, the perpendicular distance between the two vectors is calculated, and that's how dot product is measured. So these are some of the semantic or vector search methodologies that AI/ML applications use, and to calculate the distance between two vectors. Hey guys, so let's put everything together and understand where does embedding models and vector embeddings play an important role in any AI ML application. Okay. So as you can see on the left side, data from various sources, basically data, unstructured data, structured, gets converted into vector embeddings using embedding models. So as we discussed right before, we have numerous embedding models from different platforms like OpenAI, Cohere, TensorFlow, Hugging Face. So all these platforms provide us with embedding models that we can use to convert our data into vector embeddings. Basically, the whole document, right? The structured, unstructured data gets split and gets chunked, and each chunk is assigned with a numerical value, as you can see here in the vector embeddings, and that's how vector embeddings are created. And all these vector embeddings are stored in a vector database. So this is about the storage part of storing vector embeddings. And when a user query comes in, as you can see on the right side above, the user query also gets converted into vector embedding using an embedding model, right? Because as we know that vector embeddings carry the semantic meaning and the relationship between different objects. So what happens when a user query gets converted into vector embedding? It goes through the vector database to find the most similar chunk, and it retrieves that chunk using different methods like semantic search, vector search, most nearest neighbor, and it again goes through an LLM model, a large language model, to answer back to the user. So that's how you will get the response back. And that is the importance of converting your data into vector embeddings and storing it in a vector database. So yes. Hey guys, so let's see how we can create vector embeddings using different platforms, like I mentioned before. Like, so this is my notebook. I'm using single stores notebooks feature. You can use Google Colab, Jupyter notebooks, or even single store notebooks feature. It's really amazing. Uh, they have this inbuilt notebooks feature that is really fast and really cool, and it's free. You can just go to singlestore.com, sign up and start using it for free forever. They have the shared tier. You can sign up and use it for free forever. So, creating embeddings using OpenAI's embedding model. So, first things first, we need to install OpenAI and then import requests and JSON. And then we need to mention our OpenAI API key and OpenAI's format to generate text embeddings. As you can see here, our model name is text embedding ADA002. So this is the OpenAI's embedding model that we are using to convert our text into embeddings. So what is the text? So Pawan is the developer, Evangelist is the text, and we will use this text and see, and we will convert that into vector embeddings. As you can see, if you run this particular, first, you need to mention this OpenAI's format to generate text embeddings, and then you will mention your text that you want to convert into vector embeddings. And if you run that, it will print the embeddings for this particular text. Yeah, and you can change this text and try yourself. Yeah, you will get different embeddings. So this is about OpenAI's embedding model, and you can create, like I said, you can create embeddings using other platforms like Cohere, and here is the example of Cohere, using Cohere. You need to install Cohere, pip install Cohere, and then you need to mention the go to Cohere website and then get the API keys. It's free. OpenAI is a chargeable one, but this one is free of cost. You can just use this and go to Cohere website and get your keys. Mention it in your here where you need to mention your Cohere key, and then Same, the text here is Pawan is a developer evangelist. We are using this text to convert into vector embeddings, and the model here we are using is embed English v3 v3.0. So if you run that particular code, and this is how you'll get the vector embedding for that particular text. And we will let's see how we can create embeddings using Hugging Face, right? So this is also free. Go to Hugging Face website, and you can there also you can find the document how you can do this. But here is a simple example: pip install transformers torch, and then you can mention your text. The text is Pawan is a developer evangelist, same text. And the model name, as you can see, sentence transformers all mini LM L6 V2. So this is the model name. And yeah, if you run that code, this is how you can see the vector embeddings creation for that particular text. So we just saw how you can create vector embeddings using OpenAI, Cohere, and Hugging Face, and there are many other platforms too you can use to create vector embeddings. So here is a simple example of how you can represent unstructured data as vectors, and how you can calculate the distance between the two vectors like we saw in our example, the cat and dog. So yeah, let's go through this simple tutorial. Basically, we're gonna visualize these vectors and measure the distance between these two vectors using various methods that we discussed: Manhattan distance, Euclidean distance, dot product, and cosine distance. Okay, so again, as you can see here, hypothetically consider these vectors for to represent dog and cat. Dog can be represented using these vectors, and cat can be represented using these vectors. These are some hypothetical considerations. Okay, so install the libraries required: NumPy and matplotlib to plot our vector embeddings. And we'll import the libraries, and we will mention basically the axis, labeling our what should be our x-axis, y-axis, and the z-axis. As you can see, x-axis is all about weight, and y-axis is about height, and z-axis is about the age. And this is all hypothetical. I just want to show you how you can represent unstructured data as vectors and find the distance between these two. And yeah, as you can see, this is how cat and dog can be represented once you run this particular code. Okay, this is the blue one is dog, and the cat one, the green one is cat. And now let's see. Now we represented our unstructured data as vectors, and then think that that's how it is stored in a vector database. And now let's find out the distance between these two vectors. Okay, so Manhattan distance, like I said, right? Manhattan distance is like calculating the total distance you would travel between 2 points, if you could only move in straight lines, right? How could you move in straight lines? That is like you using stays, right? Step by step. So this is the formula, L1. This is the formula you can use to calculate the Manhattan distance, and the Manhattan distance is 9. It says Manhattan distance is 9. And Euclidean, next is Euclidean distance. Euclidean distance is like the straight line distance between 2 points, right? We have two vectors, as if you could draw a straight line from one point to another, right? So this is here. This is basically the formula to calculate that. And you can easily see that the Euclidean distance between these two vectors that we represented, cat and dog, it is 5.7 something like that. And next, the cosine distance. Cosine distance is a measure of orientation rather than actual distance. It's like comparing the directions in which two arrows are pointing, regardless of how long the arrows are, or where they are located. So This is the formula to calculate the cosine distance between the vectors that we have represented, and we see that it is 0.9947 something. And the next one is dot product. The dot product is like measuring how much one vector goes in the same direction as another, right? It's like comparing two arrows and seeing how much one arrow points in the same direction as the other. And the formula is very simple. You can see 773 is the dot product distance between these two vectors. Yeah, I'm going to share the link for these repos in the comment in the description, and you, so that you can just go through and then see yourself. You can try and see yourself how all these methods are calculated. Thanks.